So we are still looking at the circle theorem. All right. So we're still looking at the circle theorem, and now we are in chord properties. So the other day, the class preceding this one, we looked at was I think the angle at the center, the angle at the center of the circle being twice the angle at the circumference. So we talked about that the angle at the center is twice the angle at the circumference. And then the angle at the center and the reflex angle at the center, those two angles at the center, the their sum equates to 360. So we were also able to identify what angle at the center works with what angle at the circumference. That was from the last class, because if you have two circumferences, of course you would have two centers. So we're able to identify what angle works with what center, and what angle at the circumference rather works with what center. So today we have progressed from the angle at the center being twice the angle at the circumference, and we're now in the chord properties. Chord properties. So when we started this whole stuff, we talked about a chord, and we looked at what a chord is. So today we'll look at some of the properties as relating to a chord. So let's say that this is the center of the circle. That's the dot we have there. Is the center of the circle, and then we have a chord which is not a diameter. Remember we talked about a chord which is not a diameter. We said maybe you have the chord here, any line segment that cuts or meets the circumference of the circle at 2 points. Then we have that a line coming from the center of the circle to bisect the chord at the center. So here we're having a line coming from the center of this circle to bisect this chord at the center. Then of course we have this as a radius, and we could also have another radius here. So this is a radius. Now there are three things that we need to be able to identify here. Three things we need to be able to identify. One is a chord. The chord will be, I think I should have instead drawn this with different colors, so we can use colors to rhyme what each of these parts is. Okay, but the chord is this horizontal line. Let us say, I think that's what we'll have to do. We'll have to use colors to deal with this. It will be easier. Okay, so here I would use purple. From here to here, purple. Then for the radius, use here. Okay. All right. So we're using colors so that it should be easier to identify. Now, there are three parts to what we have here. One is the radius. You're already very familiar with the radius. The radius is the green. So the radius is the green line. So here we can say that the green is the radius of the circle. Then the purple, when you're told that the distance of the chord from the center of the circle, that means they're referring to the purple. You can see the center of the circle there, and then you can see the chord at the center, at the bottom. The distance of the chord from the center of the circle, that would be purple. So here we say distance of chord, from center. So the purple is the distance of the chord from the center of the circle is the purple line. Then, of course, lastly, we have the chord itself. So the chord itself is the black, that one, the line at the bottom. So the line at the bottom will be the chord. So most of you guys that were here in the previous classes already knows what the chord is. So the line, the black line there is the chord. The green lines are radii, that's the radius of the circle. Then that purple line is the distance of the chord from the center of the circle. The chord is the black one at the bottom. Distance of the chord from the center of the circle. Now you would have to be able to identify these three things properly because that is what you would be using in your calculations. You'll be needing this in your calculation. So you have to be able to identify when you're told the distance of the chord from the center of the circle, you should be able to know where to put that value. The length of the chord is so so and so. You should be able to know where to put the value. The radius of the circle is this. You should be able to know where to put the value. Now we will look at this is just an illustration to show you the three different parts that you'll be working with. So now let's try to take a question. And first look at this. Does anybody have any, can everybody here in the class identify what the distance of the chord is, what line it is, what the chord it is, and then the radius itself? Can everyone identify this? Okay. All right, so I'll ask you quick questions before we proceed to examples because it's very important that you are able to identify each of these three things. So I'll ask I'm only saying how many persons here. All right. So I'll ask Efosa, are you just joining? Efosa, can you hear me? Okay, not responsive. Winner, can you hear me, Winner?
Class.
Okay, Winner, if you're told here, if you're told here that a distance and the distance of the chord from the center of the circle is 10 centimeters. Tell me where in this circle would you put the 10 centimeters? The green line, purple line, or the black line? The distance of the chord from the center of the circle is 10 centimeters. Where would you put the 10 centimeters? The what? What did you say? All right, I couldn't
I
hear
think you
that.
repeat the
And
question.
I was asking if you're told because before we can start solving, you guys need to be able to identify these three things I wrote out here. I use three colors for the lines. I use green, I use purple and black there in the circle. So I am asking if you're told that the distance of a chord from the center of the circle is 10 centimeters, where would you put the 10 centimeters? What on which lines here? Green, purple, or black? Distance of the chord from the center of the circle is 10 centimeters. Where would you put that value?
The purple line.
Okay, the purple line. All right. So let's take an example. Here we have That this. So let's say we have a circle here, and then we're attempting to determine the distance of the chord from the center of the circle, for instance. So let's say this is the chord, this here. All right. Then let's say here at the radius we have 7 centimeters, and then at the bottom we're having 10 centimeters. Now the question is find the distance. The question is find the distance of the chord from the center of the circle. All right, so that's the question. Find the distance of the chord from the center of the circle. Where are you looking for? Who can tell us where are we looking for here? What line? Christine, we're looking for the distance of the chord from the center of the circle. Where are we looking for here? In this diagram, what line are we looking for? The length of what line are we looking for?
Is it the radius?
We have the radius. The radius is 7 centimeters already. You see it here? The radius is 7 centimeters. That's the distance from one point on the circumference to the center. So we have the radius green. Green for radius, purple for distance of the chord from the center, black for length of the chord. Now look at what we have here. We have the radius at 7 centimeters. We have the length of the chord. The length of the chord. See, the chord is that horizontal line at the bottom that touches the circumference at two parts. We've talked about this long before now. Now, the question says find the distance of the chord from the center of the circle. The chord is a horizontal line. Look at the center of the circle, the dot at the center of the circle. So where in this diagram are you actually looking for? What lines? Yeah, I told you there are three lines: radius, chord, and distance of chord from the center of the circle. So which of these lines are you looking for? Find the distance of the chord from the center of the circle.
The distance of the chord.
What line is it? That is the vertical line, is it not?
Yes, the line in the middle of the triangle.
Yes, exactly. So the line at the middle of the triangle, that's, let's say, the height of the triangle. That's what you're looking for. Center of the circle at the top, chord at the bottom. Find the distance of the chord from the center of the circle. Look, this is an illustration. That's why we can't rush this, because this is something that you guys always find difficulty with, and I just think it depends on how you're taught. That's why. Otherwise, there's nothing here you should have difficulties with. Let's say we have a point A and we have a point B, and then someone is saying find the distance between A and B. You are actually looking for this here. The distance between A and B. This is what you're looking for. That's the arrow there. The distance between A and B. That's what you're looking for. Now look at this here. Find the distance of the chord from the center of the circle. You already know the center of the circle. That's the dot at the middle of the circle. Where is the chord? The chord is this line that whose length is 10 centimeters at the bottom. That is the chord. Now find the distance of the chord from the center of the circle. Center of the circle at the top, the chord at the bottom, distance between these two, distance of the chord from the center of the circle. So it's just like this illustration I wrote here, AB, and you're looking for the distance between A and B. That's the red arrow there. That's what you have to measure. Is that correct? Is that correct? Do you guys understand what I'm saying? Okay. All right, so you have to know this. I can't be in a hurry on this because if you do not know what each of these lines stands for, whatever you learn, it will be futile continuing if you cannot identify these three lines very well. So, like I have said before, the radius is this one here. Look at the radius of the circle. The green lines is the radius. The purple line, when they say distance of the chord from the center of the circle, you can see the center of the circle at the top. You can see the chord at the bottom, the horizontal line. So if you're looking for that distance, you would have to, that is a vertical line you see there from the top to the bottom. Then when they say length of the chord, that's the horizontal line there. The length of the chord, that's the black line. So take note. So in this question, you have been given radius. You have the radius. You have the length of the chord. You have the radius. You have the length of the chord. So what you're looking for is the distance of the chord from the center. You have radius 7 centimeter. You have length of chord. The length of the chord is 10 centimeters. So what you are looking for is the distance of the chord from the center of the circle. That is the vertical line you see there. Now, when you're working with this, especially for theory questions, it's a theory question. Of course, you know you'd have to show the working, and so that's by the way. When you're working with this, you have to pick out only, remember that vertical line is bisecting the chord, meaning the two parts are equal. So when you're working with this, you have to pick out only a right angle from the whole of this triangle. So now let's pick out the right triangle. That's what we can work with. So here we can say, okay, let's pick out this right triangle from here. Oh, I think this isn't picking out a right triangle. Okay, so because we can't work with the whole triangle, of course you can see you have radius and you have the length at the bottom. So you have to pick out only a right angled triangle since it's the line there at the middle was a bisector. So you can pick out one, the two parts to be equal. Now when you pick out one of it, you have this point here, the radius at 7 centimeters. You already have that 7 centimeters. Now, should we say that should we say this bottom is 10 centimeters? Should we? Um, who else? Christian has answered the question. So who is here? Precious. Precious. Oh, Precious is out of the class. Look has answered one question. Winner. Okay, that means I'll have to come back to Christine. Christine, the baton falls in your court again because the others, I think they're not in the class. So now we took out only a right angled triangle. I am asking, should we say that That at that bottom, should we say it is still 10 centimeters?
No, sir.
What should it be?
5.
Why?
Because it's half of the triangle.
Okay, good. Because it's half of the triangle. Um, Lillian. Lillian wasn't in the former classes, so I don't know if she would. Lillian, do you agree with what Christian just said? Not responsive. Okay. Winner. Winner.
Yes, sir.
Do you think
Yes,
what
sir.
Christian
I
said is
agree.
correct? Okay, you agree. All right, good. Because we're taking half of it, or picking out of half of it from the whole triangle. So it then means that at this bottom, instead of 10 centimeters, we should actually have 5 centimeters there. Remember, we're looking for the distance of the chord from the center of the circle, which is the vertical line that we have there. So this then gives us what formula can we use when we're working on a right angled triangle and we have two lengths, then we're looking for one length. What formula can um, do this work for us? What method, what theorem can do this? Working with a right angled triangle, and we
Sorry.
have two lengths, so looking for the third length. All right, good. The Pythagorean theorem does the work for us, the Pythagorean theorem. And then by Pythagorean theorem, we do know that the square of the hypotenuse is equals to the square of the opposite plus the square of the adjacent. The square of the hypotenuse, that is the square of the longest side, is equal to the square of the opposite plus the square of the adjacent. So the longest side is the hypotenuse. So if we do this, the hypotenuse here would be 7. So we can say 7 squared is equals to the opposite. Maybe let's call that S. Let's call the opposite S because as it is, that's what we're looking for. So let's say we call it S there. So the opposite would be S. We have S squared plus the adjacent, let's say 5 squared. Do you guys understand what I'm doing? Okay. All right. So we're looking for the value of S, that's vertical length. So hypotenuse squared is equal to opposite squared plus adjacent squared. Then that gives us hypotenuse is 7. That gives us 7 squared is equal to S squared plus 5 squared. And then 7 squared should be 49 is equals to S squared plus 25, that's the value, and 5 to the power of 2. When you collect the like terms, you would have that 49 minus 25 is equals to S squared. And this should be 24 is equals to S squared. Then to get the value of S is to find the square root of 24. So S would be the square root of 24. What is the square root of 24? 24 to the power of 2. Sorry. Square root of 24, not 24 to the power of 2. 4 point what? To one decimal place. 4 point what?
4.9. 9.
Okay. So you see here now that the value of S is 4.92. one decimal place 4.9 to one decimal place. So this is basically what you do when you are looking for, in this case, we're looking for the distance of the chord from the center of the circle. We cut out half of this triangle, that gives us the right angle triangle. Put the 7 there as the radius. Then at the bottom, we could no longer say it is 10 centimeters. That's the length of the chord because we took only half of it. That gave us 5. And the vertical line there, that is what we're looking for. That's the distance of the chord from the center of the circle. So here hypotenuse that 7 to the power of 2 equals opposite, which we referring to as s to the power of 2, plus adjacent, that's 5 to the power of 2. This gives us 49 is equals to s to the power of 2 plus 5 to the power of 3 is 25. When we collected the like terms, that gave us 49 minus 25 equals s to the power of 2. 49 minus 25 is 24, and we had 24 equals s to the power of 2. Then, of course, looking for the square root of 24, so as to get the value of s, we had 4.9 as the result. Does everybody understand this? How we got the distance of the chord from the center of the circle is 4.9. Does everyone understand this? Okay. All right. All right. So now we'll look at another question. Let's look at another question here. Let's call this example 2. We were not able to take a general work in the last class because the time wasn't enough. So I will be taking just this one, and then in the next question and the one afterward has to be one for each person as usual. Everyone has to answer a question in the class. So brace up. If you do not understand anything, please let us know now that you still have the opportunity to. Yeah. So here we're taking, what if the question isn't given in, what if the question isn't given in a diagram? What if it's given in words and you're expected to draw the diagram and represent these values there in the diagram? So because it is not all the time that the question will be given like in a diagram, just like this one is. So this is very straightforward. There are questions that might be given in words, and you are expected to be able to know where to put each of those values. So I think that's what I'll take for mine here. So I'll just say that um, the radius of a circle is 12 centimeters here. If the distance of a chord from the center of the circle is, say 4, let's say 4 centimeters. So the radius of a circle is 12 centimeters. If the distance of a chord from the center of the circle is 4 centimeters, 4, this is 5, it's 5 centimeters, determine the length of the chord, length of the chord. So in a question like this, you'll be expected to like be able to now put these values into the circle by yourself. So that's why I was telling you guys rather that you'd have to know what each of those statements stands for. You only have 3 lines you're dealing with. When they say the radius of the circle, you'd have to know where to put that value. when they say the distance of the chord from the center of the circle, you will have to be able to tell where to put that value. And of course, when you're asked the length of the chord, you'd be able to know what to put there. So this question says the radius of a circle is 12 centimeters. If the distance of a chord or the distance of the chord from the center of the circle is 5 centimeters, determine the length of the chord. So this time we're looking for the length of the chord. So I'll draw the circle and I'll try to determine where I have to put those the numbers, the values I meant rather. So I think this is okay. Okay, so this is my circle. Then I'll try to map out the center of my circle. That should do as a center. Next is the chord. Okay, let's say I have the chord here. This is my chord. Distance of the chord from the center, radius. This is bent radius, and then the other radius as well. Okay, now I'll go back to the question so that I'll be able to know where to put each value in this each value in the diagram. So the question says that the radius of the circle is 12 centimeters. I'll have to put my radius here, 12 centimeters. My radius should be here, 12 centimeters. This other side too is a radius. The other side is also a radius, so both of them would be the same. All right, then if the distance of a chord from the center of the circle is 5 centimeters, the distance of the chord, this is a chord, the chord is a horizontal line at the bottom, and the center of the circle is the place where I have that dot at the middle. Now they said if the distance of the chord from the center of the circle is 5 centimeters, it means that it is this vertical line that is 5 centimeters. Then determine the length of the chord. Determine the length of the chord. So I am actually looking for the bottom, the length of the chord, that is the bottom, the horizontal line at the bottom, that is the chord. So they're asking me to look for the length of the chord. This is not that we have looked for length of a chord before when we said 2r sine theta over 2. That's when you're dealing with theta. That's when you have a what is it called, an angle. So that's when you use the length of theta over 2. But in this case, where you're dealing with a triangle instead, you're having lengths of sides. You're not working in the form of a sector or segment where you have an angle, the vertical angle. What you do, as usual, you still have to half of this, cut out half of it, a right angled triangle from there. Cut it out, bent. You cut out a right angled triangle from there. This isn't drawn to scale. The right angled triangle doesn't look. I think this still looks okay. Okay, so here we have the radius would be 12 centimeters. We have the distance of the chord from the center. We have here as 5 centimeters. Remember, I told you those two slant lines, they are both radii. So it doesn't matter which one you're taking. You can cut out the one by the right, you can cut out the one by the left. So the radius will still be the same, 12, 12. Radiuses are the same in the circle, except it's a concentric circle. So this isn't. So the radius is 12 centimeter. That's what I put there as the slant side, that's the hypotenuse. Then at the vertical length, that's the distance of the chord from the center of the circle, I put 5 centimeters there. Question says determine the length of the chord, which is the bottom, the horizontal line there. So I am taking out only half of that triangle to deal with. So again, I can decide to say that let this horizontal be s, the horizontal length, let it be s centimeters. Now, still employing the Pythagorean theorem, by Pythagorean theorem, we say that by Pythagoras, we still have that by Pythagoras, we still have the hypotenuse square is equals to the opposite square plus the adjacent square. So if we do that, our hypotenuse happens to be 12, as you can see, 12. So 12 to the power of 2, 12 to the power of 2 is equals to our opposite here, we can say it's 5, 5 to the power of 2, then plus adjacent s to the power of 2. 12 to the power of 2 is 144, so 144 is equals to 5 to the power of 2 is 25 plus s to the power of 2. Do you guys understand what I'm doing? Do you understand what I'm doing?
Yes, sir.
Okay, all right. So when we collect the like terms, we would have 144 minus 25 is equals to s to the power of 2. Subtract this, 144 minus 25 would be what? 119, I think, equals to s to the power of 2. And then to get the value of s, simply say that s is equals to the square root of 119. So what's the value of s? S is equals to what? Square root of 119. What's that value?
10.9.
40.1.
10.9. Sorry? Okay, so 10.9 centimeter. S is 10.9. Now listen, I need you to pay attention to this. We've gotten the length at the bottom here as 10.9. That's the value of S, 10.9. So we've gotten it here. The length of S there, 10.9. Now, would you say, because in the original question, we're told to determine the length of the chord, and you know the chord, when we drew the circle, the chord is any line segment that meets the circumference of the circle at 2 points. At 2 points. So meaning the length of the chord here is that horizontal line from the left to the right that touches the circumference at those 2 points. Well, when we're working, we had to cut out only half of the triangle and then put at the bottom there, the length of the bottom, we said let it be S. So it is that value of S that we have been able to get now as S equals to 10.9. Now, question, do you think the length of the chord is 10.9, or is there something else that I would have to do? So I'm directing this question to look at the board clearly because I'm about to leave the board. So do you think that the length of the chord that we have been asked to find, we were told to find the length of the chord. Do you think the length of the chord is 10.9, or is there something else that I'll have to do to have a different answer. So this question is being directed to, okay, yeah, I see that, but I actually want to direct the question to someone. There are just 4 persons remaining in the class. Lillian wasn't responsive the other time. Lillian, can you hear me? Okay, Lillian isn't responsive. Winner has answered the question. Oh, okay, Lillian. Lillian, do you think, unmute your mic. Do you think that the length of the chord is 10.9?
No, sir.
So why do you think it isn't, and what do we have to do to get the length of the chord?
I think it's not because while we're solving, we solved a half triangle. Meanwhile, in the diagram, it's a full triangle.
Okay, so the length of the chord has to be full, right? We took out only half of what we have there. So what should be the length of the chord? What should we do to 10.9 to get the actual length of the?
So we are going to add it. We are going to add it like 10 plus 9, 10.9 plus 10.9.
Okay, so we're going to
You
add
get the
10.9
answer.
plus 10.9 or multiply it by 2. Okay, let's see if others would agree with you. Let's see if others would agree with you. Winner, did you hear what Lillian just said? Okay, Winner isn't responsive. Christine, do you agree with Lillian?
Yes, sir.
Do you have a different reason, or do you want to explain why?
No, sir, she's correct, sir.
I want to hear your explanation why you think she's correct.
We're solving for the full length of the chord instead of half.
Okay, Lucas, Lucas, do you have something to add to these reasons that Lillian and Christine just gave? Do you think it is insufficient? Do you think you have something else to add to this?
No.
So their
Okay.
reasons, the reasons both of them gave is very sufficient, right?
Yeah.
Okay. All right. So that actually is the reason why we can't leave 10.9 as a result, because we're actually looking for the length of the chord, and the length of the chord ought to be the full length there. And when we're working, we only took half of it. So that S there isn't the length of the chord, it's only half of it. Then to get the final result, we would have to say that length of the chord, length of the chord is equals to, just like Lillian said, you can say 10.9 plus 10.9, and you get the results there as 21.8 centimeters. So this would be 21.8 centimeters as the length of the chord. You can either do this, or you just simply say 10.9 times 2. 10.9 times 2. That's multiplying it by 2 to get the full length. When you do that, you still have the same result, 21.8 centimeters. Does everyone understand this? All right, so it's almost time, but you're not escaping this time. You guys escaped the last time. I won't allow you escape this time. So um, we're taking it in this order. I'll just follow what I see here. I am Winner. Sometimes she's not responsive, so I don't know. Winner, can you hear us? All right. So, okay. So we now you're taking the first question. Lucas, second question. Lillian, third, and Christine, fourth. So let's just deal with this. We take a circle. Um. Okay. Let's take this circle here. I'm marking out the center with the dots there. Then chord. No, I'll use a different position this time. Have the chord at the top. Doesn't matter where the chord is. Okay, so this. Now, length of chord. Let's say we have the length of chord as 20 centimeters. 20 centimeters. The distance of chord from the center of the circle is 7 centimeters. No, there's 7 centimeters. All right, find radius. Whose question was it here? Winner, this is yours. This question is yours. 20 centimeters there at the length of the chord, 20 centimeters. The distance of the chord from the center of the circle, 7 centimeters. Find radius. Find the radius. So this question is for winner. This question here is for winner. Then Lucas, you're next. Your question, winner, have you gotten your question? I have to go out from that page. Have you gotten your question, winner? Okay, so I'm leaving that page. Lucas, your question. This is your question. Sharp, sharp. You guys start solving. Lucas. Um. Um. Okay. Let's say radius is radius is 6.5 centimeters. Distance of chord from the center is radius 6.5. Distance of chord from the center 3 centimeters. Find length of the chord. All right, so look at this question now is yours. Lucas, radius is 6.5 centimeters. Distance of chord from the center is 3 centimeters. Find length of the chord. Just write out the information in radius equals 6.5. Distance of chord from the center 3. Find the length of the chord. So can I leave this part, Lucas?
Yeah.
All right. Lillian, can you hear us? Lillian. Okay. All right, it's your turn. Lillian. Remember, I told you you would have to be able to identify when they tell you something, you have to be able to identify where you're putting that value. So Lillian, let's say the radius is 11 centimeters. length of chord is radius 11. Length of chord 12 centimeters, no, 13 centimeters. Find the distance of the chord from the center of the circle. Okay, so Lillian is taking this one. The radius is 11 centimeters. The length of chord is 13 centimeters. Find the distance of the chord from the center of the circle. Lillian, have you taken yours? Have you taken your question, Lillian? Should I go back to the? Okay, so this is it. For Lillian, this is Lillian's. The radius is 11 centimeters. Length of chord is 13 centimeters. Find the distance of the chord from the center of the circle. Christine, shall we begin yours? Okay, I'll give you your question following the pattern of your actual GCSE as regards this topic. So, are you writing for higher or foundational? Your exam, higher or foundational?
Higher, sir.
Higher, okay. For higher, this is the pattern of question you will see. The same thing for those of you doing WAEC, you might also want to copy this Christine's question because in WAEC, you would definitely see these as, I wouldn't say definitely, because I don't know if they would repeat it, but yeah, you should expect to see things like this. So you might want to also attempt this one. So let's say here we have the center. Um, no. Okay. And the bottom. Okay. Should I use here? 10 centimeters. Here, let's say this is 10 centimeters. Let's say this is 6. No. Give a radius instead. 6 centimeters. 6 centimeters. Then at this bottom, that was 10. So let's say here is 8. Okay, so Christian, this is your question. The question would be find the distance between the two chords. So this is for higher. Same with WAEC. Everybody has to also So for white, NECO, and yeah, GCSE, but higher, not foundational. Okay, so there are two chords here. As you can see, one of the chord has a length of 10 centimeters. The other chord has a length of 8 centimeters. The radius of a circle is always the same. That's why the two radiuses are the two radii are the same. Now find the distance between the two chords. What you have to do, you have to find the distance of each chord separately, and the distance between the two chords is the total vertical distance you can see there between the chord at the top and the chord at the bottom. Do you understand what to do, Christine? All right, good. Okay, so this is what you guys are taking. This is actually an assignment. In the next class, you tell me your answers before we proceed. So this is the end of this topic actually. There are other circle theorems, but I think if I have to follow the patterns of your exam, these are the two basic ones. Yeah, but there are more of it. You still have up to like 8 different ones, but we can't just depend on focus on just the cycle theorems, and there are still a lot of other topics we'll have to look at. So we're ending the cycle theorem here actually, but these are the most common that we've treated, or what we've treated. These are the most common. So before we commence the next class, you send you tell me the result you have, and then we'll quickly look at it before we start the next topic that we'll be dealing with. So is this okay for everyone? Do I have to go back to your questions? Is this okay for everyone? All right, do not forget, first question. This question is winners. This is winners. This question is winners. This question is Lucas's question. This second radius is 6.5. That's Lucas's. Lillian, the radius is 11 centimeters. That's Lillian's. Then Christine's is this. It looks as if it's the most difficult, but it's actually the easiest today to do. So yeah, so this is where we're ending the class for today. Next time we'll be going to another topic, like I've said earlier. Do you guys have any questions so far? Christian, have you taken down your question? Okay, so do you guys have any questions so far? Do you have any question on this topic? Okay, no. Okay, no question. All right, that means we're good. So until next time when we meet again, take care of yourself, and you guys have should I say the rest of the day? It's already night, so but have a good time tonight. Bye
Thank you
for
so much.
now. All right, bye.